Hey guys, welcome back to Java video tutorials. It's been a while, but hopefully not too long. So we're going to get back right where we left off. And I kind of went a little too far, I thought, with functions. So this might get replaced as lesson 6, and then functions will become lesson 7. But this is a pretty simple lesson, and it's over basic if statements and Boolean logic. So if you already know what that is, that's great. And if you don't know what that is, that's even better because you're going to learn. So go ahead and open up Docker Java or just watch me do it. That was fast. This is a Windows PC, guys, so everything's kind of zippy around here. And we're going to start out with a public class called if, and of course our public static void main string array args statement. Okie doke. So we need to demonstrate an if statement. So ifs are very basic and very easy. Type the word if. It's 2 letters and it is the shortest keyword in Java. After the if, it's like we're opening up a function. We can even call it the if function. We're opening up a function that takes in a parameter. You already know about parameters. Well, all if statements take in some kind of Boolean parameter. So you can have a statement that's 10 lines long as it evaluates to a Boolean. You can throw functions in here, you can throw compare operators in here, you can throw whatever you want in here as long as the end result evaluates to a Boolean inside these parentheses. So the simplest Boolean I can think of is just the keyword true. So true is a Boolean. It evaluates to a Boolean true. And so this is valid syntax. And under that we can just go ahead and open and close our braces here. And basically we're going to just type some code in here. So let's print something out. System out print line, and let's just say hi, it's true. Okay, so what's going to happen here is Java's going to go along and it sees this method and it runs the method and it comes to this if statement and it checks this condition, if true. Well, since true evaluates to true, then we will go ahead and run everything inside these 2 curly braces. So if it does that, it should print out system.out.println hi, this is true. So let's go ahead and compile that. I've already named this file if.java. So if I go to my interactions pane, I can just type in java if, and you will see it prints out hi, it's true. So let's go back and let's expound on that, because really that could be achieved by getting rid of the entire if statement. So what if we put something else here besides true, like false? Does false evaluate to true? No, false evaluates to false. So if the expression inside of these parentheses here is false, then we're just going to skip over this statement. So what do you think will happen if I compile this and then run the program? Nothing happens. Even though we have some code here, nothing happens. Question for you. Can I ever run anything inside of this if false block? The answer is no. Question for you. Will you ever see if false in actual programming? I will come back to that in about a minute. Question again. Will you ever see if true in programming? No, you won't. You will never see if true because it will always happen. There is no comparison, there is no outside variable, there is nothing that is really a condition. Now the thing is, I just encountered this today for the first time in my life. I saw if false. And if you were to ask me that 24 hours ago, would you ever use if false, I would say no. That's completely asinine and would never make sense in a program. Well, in fact, it did to me. It made sense today, and I was going through some PHP, and in fact, I was writing an application using the Cake PHP framework, and that framework has all kinds of classes and objects and methods. My IDE for Cake, Dr. Java is our IDE for Java here, but for PHP and Cake PHP I was using Eclipse. And Eclipse has this nice little feature called code completion. So if you type out a function, like if I were to say math.pow, it would come up with a little tooltip that tells me exactly what goes into math.pow. It's pretty useful if you're working in a large framework such as Cake PHP and you haven't memorized all of the different classes and methods you can use. So anyway, back to the story. I was using Eclipse with Cake PHP, and there were certain pages that Eclipse was not showing those code completion boxes, and I did not know why really. So I went on Google and I Googled the problem to see if anybody else had it, and there's a short and easy workaround, and you could have typed if false, which is going to basically make the interpreter not, or the compiler not run this code, but the IDE or Eclipse actually saw the code, and I basically just created a new object, and then everything inside of those objects was visible by the IDE, by Eclipse. So basically that gave me code completion. So that's probably so far out there and so obscure that you'll never see it again unless you happen to be developing Cake PHP inside of Eclipse. So anyway, back to our story here with if statements. If false, this is never going to run. So let's make this a little more interesting and let's create an outside variable. So I'm going to make an integer variable and call it my number, and it's going to be assigned the value of math.pow, and we're going to give it a 1 or a 5, I don't care, to the power of 3. That should give us 125. But let's say I didn't know that, so I need to test something. I say if my number, and we're going to use a simple comparison operator here called greater than, and if it says if it's greater than 100, then we can change the statement and say yep, it's greater than 100. So now let's go ahead and compile that, and I have an error here, and it says possible loss of precision because math.pow returns a double data type. So let's go ahead and cast that to an int just so the compiler knows that we don't care about losing precision, and we're going to run Java if, and you will see that it's greater than 100. However, let's go ahead and change this to 200, and you will see that it prints out nothing because math.pow53 evaluates to 125. So we need some kind of alternate case. So we want to run this only if my number is greater than 100. And for all other cases, we need an else. So here's my else statement, and basically everything inside this code block is going to run if this does not work, if this evaluates to false. Now if this is evaluated to true, we just skip over the else, not the elf. If it's false, however, then we do everything inside the else. So I'm going to go ahead and print out, nope, it must be less than 100. So there we go. Let's go ahead and compile that, and you will see that it should print out the same thing as before, and yes it did. It only says yep, it's greater than 100, and then of course if we switch this to 200, of course we'll have to switch these to 200 as well. and we can say compile, and we'll say nope, it must be less than 200, which is absolutely correct. So pretty much you have the gist of if statements. Let's get into a little bit more Boolean logic here. I'm really bad at coming up with real life examples, but hopefully you can just get this concept for now because it's pretty darn easy. This is called the logical AND operator. And basically all that's going to do is test, instead of my if test testing only one condition, and this is that one condition, it's going to test two conditions. So I'm going to say and my number is less than 200, and I'm going to go ahead and change this to 100. So it's going to test these two conditions. Say if my number is greater than 100 and it's less than 200, so that's an intersection. So any number between 100 and 200 non-inclusive will print out it's between 1 and 200. Then otherwise we can say heck, I don't know the value. Okay, so let's go ahead and compile this. And my number is of course 125. My number is greater than 100 and it's less than 200. So let's go ahead and print that out. You see, very easy. So I'm going to go back here and show you what happens if I have a logic error. A logic error is basically an error that works. It's an error with your program, although you can still compile the code. So let's say it's greater than 100 and it's less than 50. Well, if you can think of a number on the real number line that is greater than 100 and less than 50 at the same time, I would like to meet you because you would be an awesome person. Redefine mathematics and all that jazz. But you'll see this will always be false no matter what happens. So I might as well just put false there and you wouldn't see that because it's just silly programming. Actually, you might see false if it's really bad programming. I'll show you about that later, but it'd just be bad style. So I'll show you in just a sec when you would possibly see that. So that's that. I'm going to show you finally how you can do multiple conditions. By the way, before we get into that, this AND can be three different things. We can say OR. So now this would be a correct statement. I can say my number is greater than 100 or it's less than 50. So the only ones that would not be valid are between 50 and 100. So 75. 75 is not greater than 100 and it's not greater than 50. But everything else between from negative infinity to 50 and then 100 to positive infinity would be fair game. So that's that. And then I can also have the exclusive OR operator, which is the shift 6. It's that up arrow caret. And basically this says only one of them can be true. If they're both true, then it's going to evaluate to false. If they're both false, it'll be false. But if one is true and the other one is false, then we get a true. If this one is true and this one is false, then we also get a true. So go ahead and think about that. You know, if I can show you real quick here in the interactions window, I can say true and true evaluates to true, but false and true gives me a false. But if I say false or true, that gives me a true. And if I say true exclusive or true, that gives me a false. But if I say true or true, of course that gives me true. So you can see how all those work right there. And now onto the else if. So this is pretty straightforward also. I can say else if, and there is a space here. Some languages decide to combine the two, but this is not a keyword. You have to use else if. and then just have another statement inside here, another Boolean statement, and then of course we can have another code block and basically rule the world by just using a series of if and else. And if you think about it, that's really all a program is. If this, do this. If else, do this. And we just work with the environment around us and run our program based on these variables. So let's go back here and we'll just say system.out.println. It's been fun working with if. Okay, and then we need some kind of expression in here. Else if true. Now what do you think is going to happen here? Let's go ahead and change this back to an or. What is going to happen when I run this code? I want you to think about it, maybe pause the movie for a second and think about it and come back and then see what happens. Let's go ahead and run Java if, and you'll see it printed out it's between 1 and 200. So what happened here is this first statement evaluated true, so it printed this out. And then after that, since we already got one true, it skips to the very end of the if block. No else, skips to the very end. So even though this also evaluates to true, this will not run because this, we already got a true here. And this keyword else says only if this is not true. So be very careful with that. And very important thing. One other little quirk that some people might not realize is, why do you need this else? Why couldn't you just say system.out.println? Well, you probably know the answer already, but just in case you don't, think about it for a second, and what do you think is going to be different now when I compile this code and I run it? You see it prints out both of these values. So this one is printed out no matter what happens up here. But if I put this else statement here, then this one won't run if this is true. So that's great. A little bit of house cleaning. If you have one statement under your if and you know that you're not going to have more than that, you can leave off the curly braces. So I can do this, and that's just fine. And I can also say just else, and that's absolutely valid. So go ahead and compile that, and you'll see I get the same thing. And finally, here's a example of bad coding, but I have seen it before. So they'll have some kind of if statement, and they'll have a true condition. So let's say, if true, and we're going to close that, and now you'll see a semicolon. Well, my name is Java, and I'm going through and parsing this compiling this, and I see this if true with a semicolon. Well, the semicolon means in the line. Okay, we're done there. We have nothing else to do. So if I were to do this, if true, system.out.println, hi, what do you think is going to happen? It's probably not what you think. What's going to happen is it's going to run this if true. Nothing's going to happen. It'll evaluate this, but then we terminate it here. So the if is screwed up. Nothing happens. Then you have this code block with these curly braces. Well, this doesn't really follow anything since the if is terminated here. This is just kind of in open air, which is perfectly fine syntactically. So it compiles, and then it'll just run and print out hi. So no matter what we change this to, if false, compile. And what's going to happen now? It's going to print out hi, because this semicolon just destroys the entire if statement. So there's that little quirk. Plus, you might see some idiot in here going like if false, and then or if true, and then they'll put a semicolon there and they'll say else. I mean, how crazy is that? So now what happens? If true is blown out of the water, but the else follows it directly. So this will run only if this evaluates to false. So it's not going to print out high. Kind of weird stuff going on here. But, I've seen it and kind of makes me cringe. But, that's that. One more thing I didn't mention was the not operator. And all the not operator does is just negates whatever is here. So if it's not true, then it's going to be false. The else of false will be true, so it's going to print this out. And very good. So that's what this bang exclamation point line with a dot means. And I have gone for 20 minutes talking about if statements and some Boolean logic. And that's kind of long, but we need these foundation thingies. And I have a super fast upload internet connection, so I don't really care. So if there's anything else that I missed, please let me know, and donate to my site if you feel inclined to. And come back soon for lesson number 8. Hopefully we will get into something like arrays. I think it might be a time for an array. So once we do arrays, then we can get into looping, which will be fun. So see you guys later. 21 minutes and 45 seconds. Wow.